Yeah, welcome to the first edition of the Internet Networking course in the series of the journey into breaking into cybersecurity that we started. So this is going to be the first series in Internet Networking model course. Internet Networking model or network model is a very huge course, and we're going to break it down bit by pieces. So this is the first part. And today we are going to talk about the models in internet networking. I call it internet networking model because it's different from when you say networking model. So internet networking model means when there are several networks trying to communicate and how they would communicate in the background is what the model talks about. So let's talk a bit of history of how internet network model come into being. So before in the era that networking started, so there's a lot of monopolization of technology. So computers or devices from the same vendors could only communicate with similar devices from the same vendors. For example, if you're running a DECnet computer, so the whole of your organization would be running a DECnet computer. So you cannot mix and match the vendors that run within your environment or that you use. What it means is you have to be using a computer that is running a DECnet. We have to be using network devices that are running DECnet. You have to be using servers that are running DECnet. So that was the initial problem. And it became complicated because devices could not interoperate, networks could not interoperate. Then there came the era of the reference model. So the International Organization for Standardization, because it's their job to standardize technology and even things that are not technology, uh, came together in a council meeting and decided to do a model, a network model that is going to be referenced, that is going to be like a blueprint for anybody that is going to be doing communications between two technologies or between two networks, for example. So they made a blueprint, and this blueprint became a standard for everybody, for all vendors, all technology stack providers to comply with. And that model is called the Open System Interconnections Model, which is the OSI model. So the OSI model was created to address a problem, the problem of non-compatibility of communications between network devices. So that is what it was created to address, and it was created by the ISO. So ISO created the OSI model. So ISO is International Organization for Standardization, and OSI is Open System Interconnection. Model is a model. So at a glance, this is what the OSI model looks like. So the OSI model divides network communications into layers, and that approach is called a layered approach. And one of the advantages of dividing it into layers is just so that it makes troubleshooting easier. And if there is a problem at one layer, it does not affect the entire network communication. Before the advent of this layered approach or the OSI reference model, if there's a problem in a communication media or communication technology, the whole of the technology is down and nobody knows where what went wrong. So troubleshooting has to be done for the entire stack. But with the OSI reference model that divided network communications into layers, then it means that if there is a problem at one layer, that problem does not exit that layer. So it's easier to identify and know that this is a layer 1 problem, this is a layer 6 problem, and it doesn't affect other layers of communication. So it makes troubleshooting easier. It makes communication between different devices from that have different technology stack easier, and it also helps to limit the problems that emanate from one layer from spreading to other layers of the communication stack. So the OSI layer has seven. The OSI model has 7 layers. So layer model is the layered approach is created by the model. So I may be using this term interchangeably. So the OSI model has 7 layers. And this is just at a glance, just for you to see. We are going to get into the details of this. Believe me, this requires your understanding, because if you are going to do networking, or if you are going to do things like cyber security, you need to understand these basic concepts. And this is the whole essence of creating series of videos like this for people that are trying to break into technology. So there are 7 layers in the OSI reference model. Layers 7 to 1, or layers 1 to 7. We are going to look at how you arrange the layers. So the 7th layer, I'm going to do it top to bottom, is the application layer, and that is layer 7. Layer 6 is the presentation layer. Layer 5 is the session layer. Layer 4 is the transport layer. Layer 3 is the network layer. Layer 2, data link layer. And layer 1 is the physical layer. In this diagram, so it's on purpose that layer 7, 6, and 5 are put together, because that is the upper layer. It is called the upper layer, or you call it the software layer, or some people call it user support layer. So these are the names because they group together. They process the same kind of data, so they are grouped together. It's also on purpose that layer 3, 2, 1 are also grouped together, because that is the lower layer of the OSI, or you call it the hardware layer, or that is the network support layer. What connects the upper layer to the lower layer is layer 4, which is the heart of the OSI model, and that is the transport layer. So what that means is without this layer 4, uh, the upper layer and the lower layers of the OSI model would not be able to communicate, because layer 4 is what actually connects the upper layer to the lower layer, or you say it connects the software layer to the hardware layer. So this is at a glance, just for your information. Then we can begin to dismantle all of these in subsequent slides or subsequent videos, as the case may be, because I don't want the videos to get longer than expected. So before we move into the explanation of what happens at each of these layers, it is also important for you to understand the concept of data encapsulation. Simply put, and without missing what data encapsulation means, there is data and you are adding a header or a trailer to that data. Header is an additional data that is put before the data, the original data, and trailer is another data that is put after the original data. For example, you are sending a message, and that message is inside an envelope. So this is your message. So on this message, you're going to add the address, or on this envelope, you're going to add the recipient address. So you add the recipient address on the envelope. So you're adding a header because it's additional data to the information that is already in the envelope. Probably you might want to add a postage stamp. So that is also another header or a trailer, as the case may be. So the additional data that you add before the message or after the message, which makes the communication or identification of the message easier for the person that is going to receive it. So that is the header or data. And adding a header or trailer to your data is data encapsulation. So encapsulation is when you add it, and the encapsulation is when you remove the header and the trailer from the data. For example, for another example, you're sending an envelope to XYZ Street, for example, and you're sending to room 2. So what happens is if the letter gets to the postage office, they receive the letter, they look at the header of the letter. The header of the letter is XYZ Street, room 2. So then they take that letter to the specific address. So when it gets to the specific address, the recipient removes the header, which is the envelope, and it will be able to see the original message. I hope this clarifies a bit, but we're still going to look at these concepts later. It becomes clearer as we move or dig deeper into the OSI layer. But for now, just understand the concept, encapsulation. You have your original data. There is an header that is added to the data or a trailer, And decapsulation is when the message or the data gets to the destination and the header or the trailers are removed, as the case may be. So how does that apply to our OSI model or to the layers of the OSI? Remember that in the OSI model we have 7 layers. So we have the layer 7 to 1, application layer to the physical layer. So typically what happens is, in every communication there will be sender and there will be receiver. There will be a sending computer. It might necessarily not be a computer, and it might be a computer sender, and there will be a receiver. So on the side of the sender, communications go from top, which is from the application layer, to down, which is the physical layer, from layer 7 down to layer 1. This is what happens on the sender side. On the receiver side, the communication goes from bottom or from down to top on the receiver side. So it goes from down to top on the receiver side. So this is typically what happens. And if you put that together in the understanding of encapsulation and decapsulation, what it means is encapsulation will happen on the sender side. Additional information will be added to the data, and before the data is sent to the receiver, then on the receiver side, the receiver will start removing those additional data until the original data gets to the destination. So let me explain using this short diagram. At the upper layer, which is layer 7, 6, and 5, this is our upper layer. So at the upper layer of the model, what we have is data. The upper layer understands the data. It might be application layer datagram, protocol, or presentation layer data, or it might be session layer data program. So, but in any case, it is data. So the upper layers of the OSI model understand data typically. So this data, when it gets down to the next layer, which is on the, I'm looking at the sender side now, which is a transport layer, because if the data leaves application, presentation, and session layer, which is the upper layer of the OSI, the next thing is it comes to the transport layer, which is the next layer. Remember, we said that from the sender, it comes from top to bottom. So it comes to the transport layer. The transport layer does not understand data. No, it does not. What the transport layer understands is segment. It's called segment. That is the only language that transmits on the transport layer, the segment. So what happens here is, as the data comes to the transport layer is going to add a segment header to the data. So what you have at the transport layer is the data plus another header now, which is a segment that the transport layer understands. Why is the transport layer adding a segment header to the data? So that the transport layer can process the data and can understand data, because the transport layer does not understand data. It understands how to process segments. So what it does is it converts the data into segments by adding a segment header onto it. Then the transport layer passes the data down to the network layer, which is the layer 3 of the OSI. The layer 3 of the OSI does not understand segments, because that is the language that is only understood at the transport layer. So the layer 3 of the OSI understands only packets. So what happens at the network layer? The network layer just add, which is the layer 3, just add packet header to the segments that is coming from the transport layer, because what is coming from transport layer is segments and data, right? So the network layer adds packet header onto that. Why is the network layer adding packet header onto that? So that the network layer will be able to process the data, because it doesn't understand anything apart from packet. So it will add a packet header so that it can process it. So what you have at the network layer is packets. And that packet means the packet header, which has been added to the segment header that is coming from the transport layer. And the segment header that is coming from the transport layer has the data within it. So then the transport layer adds packet and send it down to the data link layer. Again, the same thing happens. The data link layer does not understand packets. So what it does is it adds frames. The only thing that the data link layer understands is frame header. So it adds the frame header to the packet that is coming from the network layer. So at the data link layer, it adds both the frame header and the frame trailer. This is where another trailer is added onto it. Why is the data link layer 2, adding a trailer? And why is every other layers not adding a trailer? So it's because the data link layer is the closest to the physical layer. And the physical layer is where the data is going to be converted. The entire message is going to be converted to zeros and ones, which is bits that can pass through wires, physical wires. So then what happens at this layer is the data link layer prepares this data for the physical layer. So it adds a frame header because it only understands frame, and also add a frame trailer. That is the only thing the data link layer understands. The data link layer were to process the packet that is coming from network layer, then there will be compatibility issues because the data link layer does not understand packet. So it adds header and trailer so that I can convert the message to the format it understands. Then the next thing is frames cannot pass through cables. What passes through cables are bits, zeros and ones. Computer bits, zeros, every cable, zeros and ones. So what it means is this frame that is coming from data link layer must be converted to bits for it to pass through the physical cable. And this physical cable might be cable, actual cable, which is fiber optic cable, it might be UTP cable, it might be some wireless means, it might be radio, but they are all considered as physical media. So it's a media of communication, or it's a medium of communication that the entire message will pass through. So the frame that is coming from the data link layer goes into the physical layer. And at the physical layer, this is where the message is carried to the receiver because this is a transmission medium. So see this as the sender is sending the message through Wi-Fi. The Wi-Fi in this case is the transmission medium, or through radio or through fiber. So these are the transmission medium, and this is what you find at the physical layer. So the physical layer sends the bits, zeros and ones, to the physical layer of the receiver, because the physical layer of the sender and the physical layer of the receiver are connected, are directly connected, either directly connected by cable or directly connected by wireless means, but they are directly connected. So these bits, zeros and ones, moves into the receiver end. Then what happens again? What has happened on the sender's end is encapsulation all through, because headers and trailers have been added to the data. So when it comes to the physical layer of the receiver, the physical layer of the receiver reassembles the bits, the zeros and ones, and converts them into frames. So when it converts them into frames, so what happens here is the data link layer here sees this is a frame to remove this trailer, to remove the trailer and the header. So when it removes the trailer and the header, because that's the only thing it understands from the entire message, so it just read off the frame header and the frame trailer. Then it passes the remaining of the message to the network layer. Now the network layer only understands packets, so the network layer of the receiver also reads off the packets, the packet header, then it sends the remaining segments and data to the transport layer. So the transport layer again also understands segments. So I mean the transport layer of the receivers now. So the transport layer of the receiver only understands segments. So it also reads off the segments header and it passes the data into the upper layer of the OSI. The upper layer is the session layer, presentation layer, and the application layer. So this is how the data now gets to the upper layer, then before the receiver now receives the data. The nitty-gritty of what happens at the upper layer are going to be discussed eventually when we are discussing the various functions that are found at each layer of the OSI. But this is just for us to explain how encapsulation and decapsulation applies to OSI OSI model, and I hope this has been helpful. So what happens at the sender's end is from top down communication and its encapsulation. So headers and trailers are added to the data to convert them to the format that the subsequent layers will understand. At the receiver's end, what happens is decapsulation. Headers and trailers are removed from the message so that they can be converted to the format that the upper layers understand. And what connects the sender and the receiver together is the physical layer. And nothing passes through the physical layer except bits, zeros and ones. So this explains the concept of encapsulation and decapsulation in the OSI model. So now, what happens at each layer of the OSI layer? So in the next video or in the next release, we are going to examine the features and the functions of each layer of the OSI. And with this background understanding that we already had about the OSI model, the layers, the encapsulation and decapsulation, it is going to be easier for us to now explain the functions so that you don't have to cram the functions. If you understand how the data is broken down on the sender side and how it's reassembled on the receiver side, then when we are explaining the functions at each layer, application layer, presentation layer, then it's going to be clearer. Bear in mind that if we're talking about the function of each layer, we're going to be talking about the functions in two ways. So we're going to be talking about the functions on the side of the sender and what is the function on the side of the receiver. For example, what does the application layer do on the sender side and what does it do on the receiver side? And we're going to be combining both together to form the functions of or the features of the application layer. On this note, I'll come to the end of this session. Remember, we said that it's going to be a very short and brief session. In the next release, we are going to look at what function you find at each layer of the OSI model. Click on like, click on subscribe, and hit on the notification button if you like this video so that you can get notified of subsequent videos. We are going to release a lot of series and it's really going to be explanations from an experienced point of view. Thank you very much for your time. Do have a wonderful time.